All right, let's jump right in. Today, we're going to unpack a really powerful concept in the world of AI called ensemble deep learning. And it all boils down to one simple but profound idea: why a whole team of AIs is almost always way, way smarter than a single lone genius. Let's get into it. So, let me ask you a question. Think about the smartest, most brilliant expert you can imagine in any field. Even they have blind spots, right? They can't possibly know everything, and you know what? Sometimes they just get it wrong. Well, it turns out the exact same thing is true for AI. And this leads us to something you could call the lone genius problem. See, you can have a single, super complex AI model that is incredibly powerful. But no matter how good it is, it's still just one perspective. It can become brittle, maybe a little overconfident, and it's definitely going to miss some of the nuances that other viewpoints might have caught. Now, at the heart of this issue is a fundamental trade-off that every single model has to deal with. It's this constant balancing act. If your model is too simple, it's got high bias, meaning it just glosses over important patterns. But if you make it too complex, it's got high variance. It starts memorizing all the random noise in the data instead of the actual signal. Trying to nail that perfect balance with just one model is, well, it's incredibly tough. And this brings us to the big aha moment. Instead of pouring all our energy into building one flawless, perfect AI genius, what if we just built a better team? What if we created a committee of AI models that could work together, cover each other's weaknesses and combine their strengths? That, right there, is the entire idea behind ensemble learning. So this flowchart you're looking at, this is going to be our roadmap for this whole explainer. It pretty much lays out the entire landscape of ensemble deep learning, from the core theory all the way to real-world applications. We're going to use this to see exactly how these powerful AI teams are built and why they work so darn well. If you need a simple way to remember all this, just think of it as the wisdom of the crowd, but for AI. It's that same basic principle. The collective intelligence of a diverse group is often way more powerful than the smartest single person in that group. Okay, so that covers the why. Let's get into the how. How do you actually build one of these teams? Let's go back to our blueprint and zoom in on the ensemble strategy part. This is where we find all the different recipes for creating these AI squads. And the very first choice you have to make is what kind of experts you want on your team. You've basically got two options here. On one hand, you could build a homogeneous team. This is like getting a room full of brilliant heart surgeons together. They all have the exact same kind of expertise. On the other hand, you could go for a heterogeneous team. That's more like bringing in a whole hospital diagnostic team. You've got the surgeon, a radiologist, an anesthesiologist. Everybody brings a different skill set to the table to solve a much more complex problem. So, once you've decided what your team looks like, how do you get them to actually work together? Well, our flowchart points us to three classic methods, and each one has its own really clever approach. Let's break them down. First up, we have bagging. The best way to picture this is like polling a panel of experts. You train a bunch of AI models at the same time, but each one sees a slightly different version of the data. They don't talk to each other, they just learn on their own. And when it's time to make a decision, you just poll them all and take a majority vote. Super simple, but it's incredibly good at reducing errors. Next up is boosting, and this is a totally different philosophy. Here, the models learn one after the other, kind of like a relay race. The first model gives it a shot and makes some predictions. Then the second model comes in and pays extra attention to all the examples the first model got wrong, trying to fix those specific mistakes. Each new expert that joins the team gets better and better by focusing on the toughest parts of the problem. And finally, there's stacking. This one is probably the most sophisticated of the three. You've got your team of expert models, and they all make their own predictions. But instead of just taking a simple vote, you train a whole new model, a manager model. And its only job is to learn how to intelligently combine the predictions from the others. It figures out which experts to trust and when. Okay, these strategies are really clever, but what are they actually good for? What's the point? Let's look back at our chart one more time and shift our focus over to the applications section. This is where the theory hits the road, and the impact is absolutely huge. The truth is, ensemble methods are pretty much everywhere. In healthcare, they're being used to combine different models to get more accurate diagnoses. The speech recognition on your phone, it's using ensembles to be more robust. Self-driving cars rely on them for better image classification. Financial institutions use them for forecasting. This isn't just theory, it's technology we're all using every single day. And you know what? This field is not slowing down. As our flowchart shows, there's a whole section on conclusion and future work, because researchers are constantly coming up with new, more efficient ways to build and combine these AI teams. They're always pushing the boundaries of what's possible.
So, if there is just one thing you take away from all of this, let it be this. By combining multiple AI models, we can build systems that are just flat out more accurate, more robust, and more reliable than any lone genius AI could ever hope to be. It's the power of collaboration, just written in code.
And this all leaves us with a really fascinating question to think about. We've taught machines how to collaborate with these foundational methods, like bagging, boosting, and stacking. But what comes next? What are the new, even more complex forms of teamwork that we're going to invent for artificial intelligence? Because it feels like this collaboration is really just getting started.